Hello and welcome. Today we are digging into something that's truly the backbone of all networking, IPv4 addressing. If you've ever wondered how your computer finds a website across the globe, or even just finds the printer in your own house, well, you are in exactly the right place.
Welcome to the ASM Educational Center video. Today, we will talk about Section 1.7 from the CompTIA Network Plus exam.
Every single IP address has a purpose, a story it's trying to tell. Some are designed for the whole world to see, some are meant to be kept secret, and others are basically a cry for help. So, let's get into it and learn how to read these digital stories.
Okay, first things first. You've got to understand that the IP world is really split into two. There's this massive public world of the internet, and then there's the cozy, private world of the networks we use every single day.
Here's the easiest way to think about it. A public IP address, that's like your home's street address. It has to be totally unique in the entire world, so the Postal Service, or in our case, the internet, knows exactly where to deliver the mail. But a private IP address, that's more like an apartment number. It only makes sense inside your building. The mail carrier doesn't care about apartment 3B, they just need to get the package to the building's main address. Public IPs are for global traffic, while those private RFC 1918 addresses are strictly for internal use.
All right, if you're studying for the exam, this slide is gold. Memorizing these 3 private IP ranges is absolutely non-negotiable. Seriously, these are the addresses you'll find inside almost every home and business on the planet. You have to know the 10. range, the 172.16 through 172.31 range, and of course the incredibly common 192.168 range. Burn these into your brain.
Now, beyond just public and private, there's a whole special dialect of addresses out there, each with a very specific job. Think of them like the utility players on a baseball team. They aren't the stars, but they have unique, crucial roles to play.
So if you're troubleshooting and you see an IP address starting with 169.254, that is a massive clue. It's your computer basically shouting, hey, I can't find the DHCP server anywhere. This is what we call APIPA. It's a fallback system that lets devices on a single link talk to each other, but it can't get you to the internet. For a technician, seeing an APIPA address is one of the clearest signs of a DHCP problem.
And then we have this guy, the loopback address, 127.0.0.0.1. This is literally how a computer talks to itself. It's the ultimate local call. When you send network traffic here, it never even hits the wire. It just loops right back inside the machine. It's fantastic for one simple thing: testing if your computer's own networking software is working properly. Okay, so we have all these addresses floating around. How do we keep things organized? Imagine a giant network with thousands of devices all yelling at each other at once. It would be total chaos. And that's where the beautiful art of subnetting comes in.
Subnetting is how network admins bring sanity to that chaos. They take one huge block of addresses and skillfully chop it up into smaller, more manageable pieces. We call them subnetworks. Doing this makes the network way more efficient, a lot more secure, and it stops devices from constantly broadcasting messages to everyone. It really cleans up the network chatter.
Now, let's clear up something that trips up a lot of students: CIDR versus VLSM. Here's the absolute key difference, so listen close. CIDR is the notation. It's how we write the subnet mask, like that little slash number. VLSM, on the other hand, is a design strategy. It's the plan of using different size subnets within a larger network to be super efficient with our addresses. So one is how you write it, the other is how you design with it. And this right here is a perfect example of CIDR in action. The moment a network admin sees 192.168.1.0 followed by that /26, they instantly know everything about its size. They know that this specific subnet has exactly 64 IP addresses in it. That little number after the slash is a powerful piece of shorthand. All right, let's take a quick look back in time. Before we had the amazing flexibility of CIDR, the internet used a much more rigid system called address classes. Now, it's pretty much legacy technology, but you definitely still need to know it for the exam.
Yeah, back in the old days, the size of your network was decided for you by the very first numbers in your IP address. Class A was for enormous global-scale networks.
Class B was for medium-sized organizations, and Class C was for small networks. Class D and E were set aside for other things like multicasting and experiments. For your exam, you just need to focus on being able to spot a Class A, B, or C address based on its starting number.
Okay, let's bring this all home. We've gone over a lot of concepts, but what do you really need to hammer down to nail this section on the CompTIA Network Plus exam? Let's get down to brass tacks.
Here is your final checklist. Number 1, memorize those RFC 1918 private IP ranges. No excuses. 2, know that 169.254 APIPA range, and know that it means your DHCP server has failed. 3, really get the difference between CIDR notation and VLSM strategy. 4, be ready for scenario questions because they're going to ask you to actually apply this stuff. And 5, you should be able to look at any IP and instantly say if it's Class A, B, or C. Got it?
So, after all of this, the real question isn't just, do you know the facts? It's, do you know the rules of the road? Are you ready to look at a live network configuration and have the confidence to spot that one IP address that's out of place, the one that's causing all the problems?
That wraps up section 1.7. Make sure to check out the next section as we continue exploring the topics in the CompTIA Network Plus exam by ASM Educational Center.